So the multi-agent AI here, Nova, which I've been making, is you can never say finished, but it's moving on quite a bit, and it's got incredible ability now. So let's ask it something. Integrate x cubed sine cubed x. Something simple there. I put on a new LaTeX rendering thing, MathJax, which is better than my old one. It's not mine. It comes from the end. You need the internet to get it, but since I'm on the internet anyway with Claude here, you can see he's thinking there. Then might as well do it. But you can do it locally on local Llama models as well. So we're just waiting for, here it
Integrating
is.
x cubed sine cubed 10. Step 1. Rewrite sine cubed 10. Using a power reduction identity, we use the identity sine cubed 10 equals 3 sine 10 minus sine 3x over 4. Therefore the integral becomes integral from 2 of x cubed sine.
So you can see it's not particularly that hard, this one, but you see the beautiful layout and how it splits the integral, and you can read it as a teaching tool. This is fantastic, combining, and you've got the final answer. I can also get it to verify the answer when it's doing it. There's a what's called SymPy, where you can get it to verify itself if you really want to do that. The other thing is we can do some incredible plots as well. Might do something. Well, let's do this. Integrate x squared y plus y squared x with respect to x and y, and plot the results in an aesthetically pleasing way. So that's a double integral, in other words. This comes off, of course, if you want that. So that's the right code as well here. It's doing two tasks. You can scroll down between in here, and the big one scrolls as well, and redox. So we're just waiting for it to do the integration, and the code will eventually appear in here. Oh, there's
Double
the code.
integration of x to the power of 2y plus y to the power of 2x. Setting up the integral, we wish to evaluate the iterated double integral. Double integral from 2 of x to the power of 2y plus y to the power of 2x.
And as we're waiting for it to do, well, it's done that, of course. We'll just see his integral, and there's the answer. I haven't checked it, but it's probably right. What the hell is this? Oh, that's the function it's drawn. There it is. 2 dimensions, x, y. Well, then x, y, and z. I said aesthetically pleasing. That's why it's not a boring plot. You can actually see it, the surface. So the beautiful layout, you can ask it, everything's not all boring maths. You can ask it to information on all sorts of things. For example, find the recent gold and silver prices for the past 3 weeks and plot them on a graph, analyzing the data. And of course, this is running on your own computer. This, well, I mean, it's running off the server, but it's running on your own computer in the sense the code is running. So it's you've got the actual code itself here, executing on your machine. So just
Running code.
yeah, so it's got the run code to, because it's got a graph in it, you see, so it's running code to get the data. I'd probably get it off a cell. I don't know where it's going to get it. Sometimes there's various servers around that gives you information like that. If it does make it up, it'll tell you. If it's just saying, well, I don't know what the data is. I'll just, they use simulated data, but so it'll tell us that if it is. It doesn't look like it is. And where's the data coming from? Oh, here we go. Gold and silver prices past 3 weeks. Silver. Just got to check the program. Not really sure where I got the data from, but looks past 3 weeks. Since March the 3rd to March the 24th. Today's the 24th, 15 trading days. So it's grabbed the data somehow. You do similar things with the weather. If it can get the data, it easily gets that. So I prefer to get things though that I know it's right or wrong. So what about this? Make up a table of Fourier transforms that is aesthetically pleasing. Back to maths again. So it's going to make up its own table. You know how you used to, well, if you're into that maths in any way, how you get tables of various things. Even I could ask it for a table of integrals, let's say. So it's it doesn't need to program for this one. The previous one, that's the coding window that it executes in. It does it automatically. If it makes a mistake, it should correct itself and go back and fix itself because it's going through the autocoder. So we're just waiting. Again, when it's flashing, it means it's thinking. The harder the task you go, it costs you more, but it's not like enormous. It's fractions of a cent that you're paying. Once you start using huge amounts of tokens, of course, the price you show it. And that's something else I need to do, is perhaps put a thing of the cost. You don't have to use the open router ones. You can use Llama models, and they're free, but then you have to have a decent graphics card running on your computer. So swings and roundabouts. I don't always listen to the voice, but the voice is kind of handy as an alarm when things are ready. Then you can just turn it off if you don't like to hear
Common
it.
Fourier transform pairs convention. The Fourier transform pair is defined using the angular frequency convention. F omega equals integral from -infinity to infinity of f t e to the power of minus I omega t log f right arrow f t equals 1 over 2 integral from -infinity to infinity of f omega.
It's very interesting that they give us the LaTeX, and it's just quite interesting. I thought, oh god, that screwed it up. But then it's given the rendered LaTeX. And that you'd get that in a book, wouldn't you? And if you want it, you're writing a book. In fact, there's your table. Does anybody need to write books anymore? That's the question. Okay, but I mean, you would just copy that bit. You don't need the rest of it. And I suppose you want some historic data. Oh, where's the second one? Sorry, before it's... Oh, God, it's another one. I'll just take this down to size. I didn't know this was coming. That's incredible. Sometimes it surprises you and comes up with things. You think, my God, how did it get that? So it did this as well. It's got that wrong slightly. So a slight problem there. The actual information is fine. It's got that wrong. So it does make mistakes, but you'll find that the mathematics is right if it's Claude anyway. He or she doesn't make many mistakes mathematically, but and very, very good at programming. That's the code for that. And let's do a historic one. Tell me a detailed history of Aberdeen from 1960 onwards. And this is where the multi-agent system comes into its own, because uh, it well, it doesn't always, but it sends out multiple agents. It's like multiple AIs looking for data. It depends on the problem, really. Um, but there's a manager that uh, a planner. So what is it? The planner gives the information to the manager, I think it is, and the manager says, right, you do this, you do that, and so on, and then they report back again to the manager, and then there's a supervisor as well that checks that the data's right on the way back, that it's not rubbish, it's not sort of presenting nonsense. So we're very strong about when the data comes back, that it's verifiable data and just a load of crap, because that's one of the problems with AI. If it doesn't get the data at once, it'll just make it up, because it's basically just a least squares, well, kind of least squares, non-linear, to get the best fit. So if it doesn't have the real data, it'll just make up data and give you something and then say, oh, there you go. So you have to, but you can counteract that by having a system, not the prompt. When you think of a prompt and you've never written an AI, you think of the prompt you normally use, the user's prompt, but there's a system prompt. Well, there's many system prompts. In fact, there's prompts for the agents, there's prompts for the main one, prompts for the manager, and so on. They've all got prompts, so you have to be very strict and state only use verifiable data, or if you can't get verifiable data, say where the data's coming from at least, and then we know. And you can be as hard as you like. So it's doing a search. Step 1 of 6. That could take some time actually to do this. I'm going to wait anyway. That's step 2 of 6. It'll produce a nice, you'll see it produces a nice document. The only thing it doesn't produce at the moment is images for that, but images would be copyright anyway, or subject to some. So I mean, you want a document that you can take away and just present, here you go, and I can use it, I can publish it straight away, as long as it's got the references. It won't have copied things. It's obviously getting the data, but you're allowed to do that as long as you write it in your own words and you reference where you got the data from. It says in here it's got data from the BBC, history, European oil capital, because it's Aberdeen, Scotland's history, 1960s, 70s. This is the system log, the captain's log. I should make the font bigger, shouldn't I? So I've used a number of the models, and the Claude one is way ahead. It's like, super intelligence compared with the other ones. But the other ones can do things. They can do basic maths and so on. But the beauty is, of course, you're not paying for them.
Aberdeen, Scotland. A detailed history from 1960 onwards. Aberdeen in 1960, the pre-oil city at the dawn of the 1960s.
I'll just put it
Aberdeen
onto the
was a
main
proud,
screen.
relatively quiet city of northeast Scotland, defined by 3 pillars: fishing, its harbour.
So the data is here, which you can look in the wee window here if you want, or you can detach it. But if I click this button, it'll come onto HTML, and you get this beautiful. Well, it's actually markdown language and HTML. It gets converted, and so now you've got a wee history, a condensed one of Aberdeen. The oil boom, I've lived through that. It's more bullet points, isn't it, than a history book. It's got Aberdeen FC's golden era. That's right, Alex Ferguson. Piper Alpha did, so that I know this is right. The reason I'm picking these things is not I'm trying to sort of show off because I come from there. It's because I know the area, and so I know whether something's factual or not. If I picked some other country, I wouldn't necessarily know whether it was making it up. And the oil price crash, yeah, it's not bad. So I left in 2000, so I don't know a huge amount about this. I made a mistake here in the setting, the typesetting, but that's all. and then a summary at the end and key takeaways. So it's got the sources at the bottom: BBC News, Aberdeen Live, Wikipedia, Press and Journal. And I think you'd agree that that's way better than Google. I mean, yeah, of course you'll get it through Google, but you'll have to go and look for it. If you get a summary, you just get a tiny little thing, but this is a huge bit of information. If you want local information, I'll just get the what should I get? Oh yeah, what's the latest weather? That's all I need to know, because it knows my location from my IP address. So it should tell me where. So it's getting the weather.
Here is the latest weather for Birkdale, Auckland, New Zealand on the 24th of March 2026. Detail value, date the 24th of March 2026 max dim.
Because it uses markdown language, it puts all these nice wee things. It's quite it's a nuisance if it's in text, but if it's in a web page, it looks fantastic. So maximum temperature today was about 22, which is not bad for this time of year. Minimum temperature 15, wind speed, and get the news. What's the latest news on the Iran conflict? So I've gone off to get the news. Let's have a look to see what it's doing. Oh, I see it had some trouble here. Some rubbish came and it cleaned it. So that's another thing when you're doing web searches automatically, you can get rubbish coming in. So the AI's got to look at it and go, oh, it doesn't look too good. Sort of looks like because you can get advertising stuff and all sorts of rubbish, and you don't want any of that. So you've got to be a little bit intelligent.
Latest news on the Iran conflict, March 2026, based on multiple live news sources: Newsweek, BBC, Sky News, Al Jazeera. Here is a comprehensive summary of the latest developments. Overview: the conflict began on the 28th of February 2026, when the United States and Israel launched strikes on Iran under an operation reportedly called Operation Epic Fury. As of date 20.
So here we are. Again, I know what's going on because I've been following the news. The Straits of Hormuz. Then there's the death toll. Iran, Lebanon, Israel, US. Political intelligence developments. And then it's got links. Let's see if they hope they work. Yeah. So the links work, so it's not rubbish. So it gets all that information. And you can do other things like YouTube, Iran conflict. Oh, Iran. You got to watch that. That's why I don't do a voice activity detector, because otherwise those things go through and you get rubbish coming out. Well, what's going to happen here? Oh, why did nothing come through? Oh, no YouTube video fine. Okay. Oh, we'll do something else. YouTube, BBC News.
Hello, I'm Sarah Campbell. It's day 24 of the US-Israel war with Iran, and over the next 10 or so minutes, we'll bring you our daily briefing with the key updates on the conflict. Let's start.
There we go. Of course, it can do cool programs as well. Just about anything you can ever imagine. Especially with Claude in the driving seat. What would we want to do that's let's just say something like oh, I know. Show me Newton's method applied to inverting a matrix step by step and show the graphs. So Newton's method's got given another name, Newton-Schultz. It used to be used in IBM computers to invert matrices. It's an old idea, but you can look at the theory of it. Hopefully it'll show me the theory of how they're inverted, sorry. So this is turning into
running code.
Here we go. This is turning into a kind of operating system in a way. I mean, you don't need a computer if you've got this. Obviously, you can add other things. This would replace the computer completely, I would say. Unless, of course, if you send in emails, that's another. We can do that. That's another add-on we'd have to do if you really want it. That would be the only other thing. Maybe spreadsheets if you're into that. I haven't bothered putting that in, but you can add tools, so it's just a matter of time, really. Oh, I see it's got the matrices here. It hasn't got an explanation. That's interesting. So it's just got a program, but gosh, that's going to be quite good. It's going to be quite sophisticated. It's looking at the norm. That's the Frobenius norm of the thing. That's the residual going down. I thought it would have actually given me a matrix, but it's showed me in more detail. Maybe I should do another one and just ask for the mathematics behind it, other than the graph. When you're doing the graph, then it's graphing it. Spectral radius, okay. Haven't heard that for a long time. We'll do that. Yeah, well, here we go. Another one appearing. Oh, I see how it's doing it. It's showing the convergence. Oh, graphically. Oh, okay, that's a bit abstract. To zero. That's the error. That's the Frobenius norm of the error. And it's showing that reducing to zero, basically. I think it is, yeah, zero, the white colour. Never seen that before used. It's a strange way to do it, but anyway, it's not going to give me any explanation, is it? I just wanted to know what oh, here it is. It's given an example here, but it didn't say what the actual matrix itself was, but you could go over it again. Here's another one. Explain in detail general relativity by Einstein and make a graphical representation of it. Make something simple, don't make it too hard. The other thing we can do, and I've done it before, is it can examine its own code, and it can also evolve, but that's experimental. I mean, these things we know work, but the evolve one is like if I say to it, add a button here to do something, next to the speech button, another button to do something or other, then it goes and does it. So that's the evolve part of it. Obviously, you do need a good brain behind it to do that. So if you use some of the smaller models, it just mess everything up. forgot my ask now. Oh yeah, it was kind of, anyway, we're waiting for it. So it's running two tasks sequentially. It's doing mathematics. Oh, it was it doing your general relativity, isn't it? Yeah. The stress energy tensor. So we'll do some graphical display, probably with a black hole or something. Gravity well. Oh, it's taking its time. Mind you, it is general relativity. You kind of don't learn that in primary school, do you? That was that previous code it wrote on the matrix inversion. There's the formula xk plus 1 is xk, 2a minus axk. Yeah, x is a matrix there, not a vector. See, its goal is to find x, so ax equals I, so x is the inverse of a. It's a little bit like MATLAB. It's MATLAB library that they use in Python, but except for it's not quite as straightforward because they use at symbols and things, make it really complicated. Whereas MATLAB's a lot easier to, but a lot of the commands are very similar, like the labels and so on, labeling the axis. But they're not the same, but they're similar. The difference is this is free, whereas MATLAB you have to pay for. If I don't like the theme, I can change it. Void Spectre, that's called. So the original one of these was made up, the GUI was made up by the creative autocoder. More or less did
General
it.
relativity,
Oh,
a comprehensive treatment, -1. Foundational principles, 1.1 The equivalence principle Einstein's General Theory of Relativity, GR, published in 1915, rests on a deceptively simple but profound observation. Gravity and acceleration are locally indistinguishable. This is the equivalence principle, which comes in two forms: weak equivalence principle, WEP, the inertial mass m sub I, resistance to acceleration, and the gravity.
So there's all the equations, field equations. I thought I asked it to do a program. I wonder if it's going to do that. I'll just wait. The Hilbert action variational derivative. Geodesic, the paths of free-falling objects. Case solutions. Gravitational redshift. Gravitational waves. This is saved, by the way, when you can visit it again if you want to see it. Black hole thermodynamics and summary of the key equations. You see how amazing it's done that. I mean, it's like who needs class notes anymore? Oh, I know another one to do. If it's not doing any coding, I thought it was asked it to code it. Oh yes, it's doing it. Here we go. So this is the way you get the wow factor. I'll just bring it in a bit. General relativity, space-time curvature, geodesic. Look at that. Quality of the graphics. Now, I don't pretend to understand it. Gravitational lensing, a little bit about that. It's basically made a poster up. So one thing I do know a little bit about, so I use it a lot in signal processing, is this. describe contour integration in the complex Z-plane and give 2 examples. So that's Cauchy's work. Cauchy, the French mathematician. It's a really elegant method in mathematics, and it's used in electrical engineering for signal processing. We don't use it a lot, but kind of need to know the principles of it to understand things about it. You don't need to know it, but you'll understand things a bit deeper if you do.
Contour integration in the complex plane. Fundamental concept. Contour integration. Evaluate.
Well, just have a quick look at that. See if the symbols came out. Oh, yeah, he has. Yeah, it's got the symbols proper. Cauchy's integral theorem. I asked for some examples. There's an example 1. Example 2. Okay. The other things it can do is it can get research papers and summarize them, and it's gradually gaining a bit more strength in what it does. So that's the latest of how it's working. Thank you.